Okay, this is Environmental Science, Wednesday, October 7th. So the coal deposits are in layers underground. So imagine what happens if those actually coal deposits catch on fire. This is a real story. 10 minutes. So let's watch. It's 3 minutes. Only 3 minutes will be good.
A few residents of Centralia, Pennsylvania, harvested a fine crop of tomatoes in December. The snow that winter all melted on the sidewalks. Why? Because a gigantic underground fire that is still burning 53 years later.
Right now.
First, some geology. Central Pennsylvania sits atop some of the largest coal deposits in the world, formed by millions of years of geological pressure. In the 1800s, miners began tunneling beneath the ground there to harvest it. By the 1900s, demand for coal dropped, and many of the Pennsylvania mines were abandoned. Back to 1962. No one quite knows how the Centralia fire started. The leading theory today is that burning trash near an old mine entrance accidentally ignited the coal beneath. Once it ignited, the fire began to spread. Coal burns when carbon inside it combines with oxygen. The tunnels provided oxygen from the surface. As more and more coal burned, the flames ate deeper and deeper into the surrounding terrain. And unlike wood in a forest fire, coal burned slowly and steadily, so the fires didn't burn themselves out quickly. So what exactly is fire? Well, fire is the visible effects from combustion. Combustion occurs when a fuel is heated to its ignition temperature. It has enough available energy to react with oxygen, creating fire. Once started, the fire will keep burning as long as there's enough heat, fuel, and oxygen to sustain it. Depending on the conditions, this is why coal mine fires might burn for centuries. Coal naturally contains its own fuel and oxygen and burns very slowly. Once started, the coals can burn until the carbon source is exhausted. Back to Centralia. Because the fires were limited to the tunnels at first, the 1,000 or so residents found the situation amusing. But other, more dangerous symptoms of the fire soon appeared. Sulfurous fumes and carbon monoxide began seeping out of the ground, nearly suffocating some of the residents in their homes. Even more scary, the fire weakened the ground and left it prone to sinkholes. In 1981, a 12-year-old was crossing a neighbor's yard when an 80-foot sinkhole nearly swallowed him. He was pulled out to safety by one of his cousins. Officials have attempted to put out the fire a few times over the years. One attempt involved dumping wet sand into holes drilled down from the surface to choke off the air supply. They also tried pumping air supply into the tunnels. In 1992, the state government condemned the city, the entire city. Today, just a dozen or so people live there. The Centralia fire isn't the only underground coal fire in the world. They're actually alarmingly common, especially in India and China, which still depend on coal to a high degree and often have lax regulations. Natural underground coal fires also exist. Around the world, there are a few thousand of them burning, compared to about 1,500 active volcanoes. The Centralia fire now reaches as deep as 300 feet and covers some 6 square miles. That's more than 7 Disneylands. It's advancing around 75 feet per year along 4 separate branches and could burn for another 250 years. All the residents of the town may be gone by then, but the coal that brought their ancestors to Pennsylvania in the first place will still be blazing.
I got this from like Britannica or whatever website, but this is actually an interesting fact. This is what can happen. And the reason it's still burning, yeah. And the reason I remember this is when the fire were going a few weeks ago. There was an underground fire. It wasn't coal mine, but there was an underground fire in Oregon. I saw it when I was checking my weather. I don't know if there'll be, if we can see if there is video about it. Let's see. When you're on YouTube, Oregon underground fires.
Have you watched Down to Earth with Zac Efron?
No, what is it?
It's called Down to Earth. He like travels the world looking at like food and kind of different cool things. And he went to New Zealand and he made bread from the fires from underground.
Oh wow!
Yeah,
Really?
that was really cool.
Oh, you're watching this guy? What's the name again? What is the show?
It's called Down to Earth.
Down there. Oh, check it. Oh, okay, I'll check it out. Oh, one more thing to watch. Like, oh, I'm so behind. I wanted to rewatch this Silkwood movie, Here is the fire in Oregon.
This problem has a lot to do.
Street.
You see how
And
it's
we're just
going
doing
there?
spot
It's
checks
crazy.
for
few
smoldering and
weeks
for any
ago.
trees that need to come down.
Don Tesdall took
Now
this
we put
video
out
over the weekend
fire
in
on the
Detroit.
Here.
We're gonna put this out, but these things are all over the hillside.
From above the mound, it might look just like a little smoke, but below it is an active fire just waiting for the chance to get out.
You've got a 1200-degree fire going on.
To inform the community of what is going on in Detroit.
So Detroit, don't it was in
This is
Oregon.
my house.
One of his first posts was last week showing what the fire did to.
Posting these videos if we still have a lot of this stuff going on well.
Yeah, they're explaining why people cannot return home, but it was interesting. So we can have those underground fires. Okay. So going back to what we're doing, which is yeah. I think I remember this kid. This is a good question actually. I remember they fined them or something, some amount of money. We can probably Google it, but I remember they were fining them. But I was thinking, how is it fair? No, but they were fining them some amount. But I was thinking exactly the same thing when I was watching this fire in Pennsylvania. Imagine if you were the person, if really somebody burned the trash, if you were this person who burned the trash, they didn't know apparently, but you live with this guilt unless you come to Jesus and admit it, I guess. But it's a good question. I think they were fining. I remember there was a fine. But we can research more. Okay. So what we're doing, we're finishing our chapter 12, which was about mineral resources. So mineral resources were inorganic, right? In the next chapter, we're going to talk about the organic ones, which are the natural gas and oil, right? And coal. They're all the organic ones. Okay. Hold on. So, okay. So there are many, there are underground, there are tons of different supplies, but not all are like equally distributed, of course, and some are more rare than others, right? For example, we have some like manganese, chromium, cobalt, platinum are relatively scarce, not so many. Like some are, we have a lot, right? So the question is, what do we do? It's not so depressing though. We're like, oh, this is the end, because usually what countries do, they when you have it, like it happened in North Korea or Korea, South or North, which Korea was it? South Korea. They had a lot of iron and copper, so they exported it. And then in 1960, they ran out of it. So now they're buying it back, They have to import it. So, okay, the countries who have a lot, they need to be careful, right? Okay, so another thing we learned is that mining is very dirty process. It's horrible. Like Grace especially can testify now after watching the movie. But there is one alternative. It's called biomining. It's using microorganisms to actually extract the mineral you want. So there is a video. It's about bio-leaching, more like. I just found it. Let's see how it's going to go. Click it. Yeah, you see it. Only 2 minutes. Good. We like short videos.
We consume an increasing amount of minerals in everyday life, but mineral resources are not inexhaustible. When we extract metals from underground deposits, many are left behind, as the remaining elements are not valuable enough to extract. This is known as mineral processing waste. To extract valuable metals from mineral processing waste, scientists began to study a natural phenomenon: bioleaching. Let's see how it works. Mineral processing waste contains minerals, but also living bacteria.
We bacteria can thrive in these piles of waste. All we need is access to air and water to multiply. But we also need energy, which we can collect by dissolving and transforming metals. This is bioleaching. In the process, we release acids that can pollute soils and cause environmental damage. To scale this process up for our needs, the scientists came up with a process to boost our metal production. To do this, the mineral matter we live in is ground into a powder and plunged into a bioreactor, a large and continuously stirred tank with water and nutrients. In this environment, we can thrive and multiply exponentially. The result is a solution that contains the metals originally contained in the mining waste. Then, all that's left to do is chemically filter the solution to retrieve the metals in solid form. This process also has the benefit of keeping the sulfuric acid we produce within the lab or factory. Otherwise, it may leach into the soil. The bioleaching process has moved beyond research and is now applied in the field. Bioleaching produces
different kind of options. You know, people, we're smart. We invent. If you can make the iPhone, this little thingy, it's like a little computer. We can do so many things. This one, I don't know. It's a good question. They probably neutralize it. You know, you can mix it chemically and probably neutralize it, or maybe they can use it for something. No? But you know, this is bioleaching. I think biomining is you're in the place. You know, it's called in situ. You go to where the piles are and just have those bacteria work, but it takes long time if you just do it this way. Okay, so we're like, okay, people are smart. Oh, can we get more minerals from the oceans? Like, well, actually we can. But so they're really cool things. These are cool. They look like that. They're called manganese nodules. See those things? They're very rich in minerals. Apparently manganese is the main thing. So some of the ideas are just going to send machines down and extract, let's say, combine those modules. Or who watches Octonauts? Maybe Elizabeth only. You've seen the Octonauts, the little show. Daniel knows it. Okay. They're very educational and they tell the truth. You know, they're like factually based. There was the episode about the hydrothermal vents. I don't know if you remember this episode, but in the bottom of the ocean, there are those, you know, vents where, you know, like from inside, you know, inside there to have like hot, very minerally rich vapor coming out and then solidifying, making those tubes. They look like tubes. Or, so the idea is to get those chemicals somehow. And here is an idea about deep sea mining. The question is it good or bad? So let's see.
I think we'll have the $5.99 steak special. I am super excited for this.
Yeah, me too. I'm starving.
Oh, here is one of those.
There's a conflict brewing at the bottom of the ocean.
So we need to shorten.
In the coming decade, it'll play out thousands of feet down in deep, dark expanses of sea floor. On one side of the battle are unique and alien-like creatures. Giant tube worms, yeti crabs, dandelion-like jellyfish colonies. And on the other side, bizarrely, are cell phones, TVs, wind turbines, modern technology. In a real way, those two interests may end up fighting over one of the most mysterious and dramatic environments on Earth. This one. Okay, so this is clearly a model. We don't have a submarine, so manganese, zinc, and cobalt are needed for batteries, and copper is crucial to countless kinds of wiring. Worldwide, humans mined around 20 million tons of copper in 2017, and those are just a few examples. The point is, elements like these power the modern world. Many of these precious metals are sourced from massive terrestrial mines, but while we chip away at our reserves on land, some entrepreneurs have been gaming out a very different source of precious minerals. In the deep dark of the seafloor, 10 or even...
Where is Pulusa? I don't know. Which direction is this? If it looks like this is a mine. Oh, there it is, I think. Pulusa, I don't know which direction do we go, but there is. She drives this way every day, no? Or the other way. Oh, this way, okay. But there is a quarry which looks a little bit like a mine in West Richland. They used to say. So probably this is what's going on. If it looks like a mine, it is a mine. Okay, let's see.
15,000 feet down, shifting tectonic plates create fissures in the Earth's crust and allow
those
hot
little
magma to seep close to the seabed. If the conditions are just right, seawater percolates through the crust, becomes a superheated mineral-rich fluid, and shoots back into the ocean. These sites are called hydrothermal vents, and for the few people who have actually seen them in person, they're almost beyond words.
It's hard to describe what it's like to go down in a submersible, which I've done a fair number of times, and you're arriving on the bottom and you're at this mid-ocean ridge where there's brand new rock that's been formed. It's basalt, it's black, and it's mostly not much living on it at all.
Dr. Verena Tunnicliffe is a professor and former seafloor adventurer at the University of Victoria.
You're driving along and all of a sudden you come into a hydrothermal vent, and there is just going from black nothing to all of this white microbial production and all of the animals around it. Temperatures up to 400 degrees centigrade, so you've got these big chimneys that are formed from the minerals, and it's just covered with life.
The first critters to take up shop here are chemosynthetic microbes. Amazingly, they derive energy from chemical reactions, not the sun, and they love the vents.
So you've got lots of microbes that are producing like mad. It's food. Now you've got lots of animals then coming in because there's food, and therefore lots and lots of animals that want to eat that food.
Researchers estimate that there may be 600 larger active vents sprinkled along mid-ocean ridges, and each one can support its own unique, vibrant ecosystem. Researchers like Verena have cataloged new species of sea cucumbers, foot-long white clams, squid worms. For biologists, it's an embarrassment of riches.
Frankly, it's very easy to find new species at hot vents, and I have lost track. I know that we've done at least 100 through the lab.
But in addition to life, there are minerals. As water passes through these systems, a complex set of chemical reactions leach minerals out of the rock. When the fluids spew back out into the cold seawater, the minerals separate out again, littering the sea floor with gold, copper, zinc, manganese, and more. There is a theoretical fortune to be made down here, and that hasn't been ignored. In 2017, Japan announced that it had completed a landmark trial mining operation near the island of Okinawa. The mining site was an inactive vent, meaning that it was no longer spewing out hydrothermal fluid. It was really just baby steps towards full-scale mining, but it spooked conservationists, because mining a hydrothermal vent really means destroying it.
So they have to go in, they have to cut out the rock, and then they have to grind it up into a slurry, and the slurry is pumped to the surface. So the habitat is destroyed, the animals are gone. The habitat is converted from big chimneys with lots of niches into mud.
In some cases, vents are naturally resilient. Those that form in volcanically active areas are constantly destroyed and reformed, and the animals there have adapted to that volatility. Verena likens them to new-growth forests that bounce back quickly after wildfires. But the sites most valuable for miners are mature, stable vents. The minerals there have built up over thousands of years.
The rocks that are deposited by the
there aren't adapted to catastrophic disruption and could be wiped out by mining. For all that, vents are probably not in imminent danger. First, if seafloor mining really kicks into high gear, it likely will not start with hydrothermal vents. There are other valuable sources of minerals in the ocean. Many are found within rocky, lumpy masses called nodules. Those are scattered across wide, flat plains on the seafloor, and they may prove easier and cheaper to harvest, which is the bottom line of any mining effort.
Okay, so here, so this is the thing. So the two options, one is to mine those vents and the other those nodules. So what do you think? What's your opinion? Should we focus on those or no? Because it seems like, if we run out of, on the surface, under the surface, we can probably go there. What do you think? Should we pursue it or not?
I feel like that's so sketchy. Like, I would not want to go down there or not. I don't know. And then just, I don't know. This sea, I just feel like you don't know a lot about it. But it is really big. And so.
So then, have you seen the Meg, the movie?
Yes.
See what happened when they disturbed it?
Yeah. Those movies are the reason why I would just not ever touch anything.
Who has seen the Meg? Oh, you're losing that. I mean, it's.
Can we watch the trailer?
I'll lend it to you. I have it. Yes, from here. It was fun. Many people who like good movies, they're like, oh, it's a junk, but I watched it like 10 times because Joshua wants to watch it 10 times or 20 times. It's a shark. Hold on. The Meg. We bought it. I paid $20. I usually wait for the movies to be $5, but he wanted this, and I was like, fine, well, let's buy it. So I paid $20 for it. Then I got from yard sale one for $1. I think I had two. I should bring it. This is environmental science movie. It's on the list next time. It's really cool. I think it's cool. I don't think so. Might be existing. I don't even know about it, but you know.
What's that?
There's a monster outside.
I'll bring it. You can borrow it.
What you people discovered is bigger than we ever thought possible. How big is that thing?
It was the largest shark that ever existed.
A living fossil.
Thought to have been extinct for over 2 million years. Wrong.
My God. It's a megalodon.
He's kidding, right?
That thing's out there. We need to find it and kill it.
Why don't you just put a tracker on it? Did you guys ever watch Shark Week?
He looks heroic, but he's kind of got a negative attitude.
Chew on this, you ugly.
Yeah, well, he plays the bad guy. Here you go. I'll bring it so you can borrow it.
You totally know what's coming the whole time.
Yeah, but it's cool anyway. So, but this is good movie. Next time I'll include it in the list of the environment, movies for this chapter. Okay. So anyway, so we need to figure out what to do with the, we can recycle, but one thing, people, since they're so smart, they're actually inventing new technologies. Yeah. Have you heard of nanotechnologies? What is it?
I use it. We use it in our detail cards.
In what?
Detail cards.
Uh-huh.
Just then we have called ceramic coating. We coat a card in this coat, put water in the paint,
Uh-huh.
and the water just swallows.
Oh, it's so cool. Yeah, it is true. But anybody else, what do you know about nanotechnologies?
I know that it's like a bunch of really, really small particles, and there's a lot of debate on whether or not it's healthy to be around them or not.
Okay, well, we're very informed. Okay. So it is no. So no, this is the hold on. So this is now we need to decide as a class. We watch a few videos, decide what we do with those. Should we do them, not do them? Okay. But so what it is, it's like you actually it's like you're taking molecules, you're manipulating, actually the molecules and building a new things. Let's say they get carbon atoms, right? And then they make, let's say, those nanotubes, they arrange them the way they want, the atoms. I can show a video, but we have so many videos, so I'll just try to explain, right? And you can arrange them in different forms and make super strong things, for example, or super small. The idea is that you can actually build a computer the size of a sugar cube. It needs to be like, let's see, a sugar cube, which could store all the information found in the US Library of Congress, for example. Or you can do like stain-resistant, wrinkle-free coating on clothes, right? Odor-eating socks, I guess. So the sock don't smell. No, odor-eating. They're eating odor. I don't know how to explain. You know that there is things like edible underwear and edible clothes. I know, I read it long ago. They sell those in Japan. I remember when I was there about this. Actually, just to gross you out a little more, in Japan, they're so crazy. They're little. I know. It's okay. This is the truth. I'm not making it up. I mean, something is wrong with their like psychology at some point. You know, the way things are arranged. But in what's the name? Tokyo, they have a machine. You know, vending machine. Grace is like, oh, what's going to say? A vending machine which actually sells used underwear. You know, you can. Yeah, no, what is true? Okay, so it is wrong, but you know what? There's crazy people everywhere. Yeah, this, but where? Oh yeah.
That they will bring back used underwear and be like, I'm going to return these. I don't want to use them anymore. Or they weren't comfortable, and I'm just like.
This, but those people have vending machines for that. You know, they're like all kinds of other vending machines, but this are I was just thinking about, since we're talking, so it's odor eating socks, you know. The socks, the socks like eat the odor so they don't smell. I think I want one of those if I see them. But self-cleaning sunglasses, who cares? Windshields. I guess self-cleaning windshield would be good on the car, you know. Sunscreens, deep-penetrating skincare products, and food containers that release nano silver ions to kill bacteria, mold, and fungi. Okay, so let's look. Okay, so sunscreen. Actually, many sunscreens have this. So let's see. I have a video about sunscreen here in nanotechnology. Let's find it right here. This is the cool examples Isaac was saying, which it's true. We'll look at them. Oh, they're right here. I think the sunscreens. Okay, let's. Expensive. Okay, so let's see. So this is the sunscreen.
Shopping for sunscreen is a complicated business.
Oh, no.
Even before you get to the big questions like, do you go for the spray-on stuff or the slap-on cream? There's the issue of how safe the product is. And that inevitably leads to the question of whether you go for conventional sunscreens, the ones that use chemicals like oxybenzone or avobenzone, or one of the newfangled nanoparticle sunscreens. And if you do go nano, just how safe are those tiny little particles you're about to spread on your skin? Nanoparticle sunscreens use microscopically small particles of zinc oxide or titanium dioxide. You can usually tell if a sunscreen...
You see those titanium oxide and zinc oxide? Okay, these are the very small, okay.
Sunscreen uses nanoparticles because it lists one or both of these materials on the label. Companies have been using these substances for a decade or so now, claiming that they make for a better sunscreen. But for some users, there are lingering doubts about their safety. So what do you need to know when deciding whether to go nano or not before braving the sun's rays? Here are 5 things that may be helpful. 1. Nanoparticles in sunscreens stay on top of your skin and don't pass through it. When manufacturers started to use these minuscule particles, researchers wondered whether they could in fact slip in between your skin cells or even get into the cells themselves. Fortunately, after several years of research, it looks like healthy skin is great at preventing nanoparticles getting into your body. 2. Nanoparticles in sunscreens work by reflecting harmful ultraviolet light away from your skin while allowing visible light through. Because of this, they create a barely visible protective barrier, which is great if you'd rather not look like you've just been whitewashed. What's more, they protect you as soon as they've been applied, unlike many of the more conventional sunscreens that need time to settle into your skin before they're fully effective. 3. Uncoated nanoparticles of titanium dioxide and zinc oxide can produce harmful chemicals called free radicals when exposed to sunlight. To avoid this, sunscreen manufacturers coat them with a thin layer of materials like silica or alumina. The layer prevents free radical formation and transforms potentially harmful particles into safe ones. 4. Non-nano sunscreens may be more harmful than nano sunscreens according to some research. Conventional ingredients like oxybenzone may lead to allergic reactions with some people, and small quantities can penetrate through your skin and into your body, where there's a chance that they may cause problems by behaving like human hormones. In contrast, at this point, there is no evidence that nanoparticles behave similarly. 5. Inhaling large quantities of titanium dioxide and zinc oxide nanoparticles probably isn't a good idea. Research has shown that even though these substances are likely to be okay if inhaled in small amounts, smaller particles definitely do more damage than larger particles if they get into your lungs. So you might just want to watch what you're breathing while using one of those spray-on nano sunscreens. Finally, whether you end up opting for nano or non-nano sunscreens or using some other form of protection, remember that exposing unprotected skin to the sun's UV rays is one option that is definitely not safe here. If you have any thoughts...
Okay, so these are the options, right, for a sunscreen, right? So this is, what's your, so the thing is with the nanoparticles, they're so small that actually they can penetrate, go into the cells themselves, and do different things, which we don't know what they do. So, especially, the spray, it always bothers me, the spray, you spray this and you kind of breathe. I'm like, why do we spray it? Can we, put it. So, what's your opinion on spray on or sunscreen or cream line? What do you use?
As long as it's SPF 50, I should be solid. Yeah, I don't know. I didn't know.
How about you, Grace?
I don't think the spray works as well as actually.
Yeah, the spray. I don't think so. To the spray, unless you need to
I
spray a
get,
lot.
I get burnt in patches if I use the spray.
Spray. So I guess you didn't do the spray. Maybe you need to spray it and then do this.
Yeah, it still doesn't work because it's like just this thin little layer. You have to like rub it.
I had a friend who asked his sister to spray sunscreen on his back. So she did like a huge S, and then he got burnt. He got burnt.
That's so funny.
That's kind of what happened to my brother when we were on vacation. He just had like all these like patches of burn and knots.
Yeah. It happened to me, because I'm kind of lazy. I don't like to put sunscreen. And then I remember I was putting it, just put a hand, and then another I didn't really, do this. And then I had the hands. Yeah, I had the hands. But it's my own fault, So I don't know the sunscreen. I don't like. I think I would go with the old-fashioned one, but this is my thing. Just because I'm like those nanoparticles. I don't know what they do. Healthy skin fine, but what if you have a cut or something? I don't know. What do you think? So this is the question. Okay, let's look at some of the cool applications which Isaac is doing, and then we need to decide. Everybody choose a side. Are you for or against using the nanotechnology, and think of a reasons? Okay, so this is the sunscreen. This is 9 minutes. I'm going to fast forward. We can just see a few of the cool things you can do. There are many more. This is just some. It's actually an old video. Okay, go. They have a nice music. So did they coded it? Oh yeah, they coded one of those. It's repelling the water. Yeah. This is just the same thing with the car. They covered one of the, or one of the nails is covered with this, the other is not. The music is kind of crazy. So let's move on. One of the gloves is with the thing, I guess. Okay, we got it. The music is very triumphant, like. Okay. Oil and oil. We got this part. What is that now? A glass. So it's a glass, how clean it. What is this? Oh, they put the. See? What is that? Hold on. Yeah, hold on. Okay. Yeah, right here. Okay, let's see. So glass center is untreated. Framed with ultra. Oh yeah. So the water will be repelled and just collects in the center. It's kind of repelling the molecules. The water molecules, they stay there because they're repelled by this thing. Huh? See, they're repelled. Funnel with ends. that. I don't know. Oh, that gets. This actually applies to the toilets. They want to make toilets which you don't need water to flush. So if it's like surface which doesn't, anything sticks to it, then what is it? It wears off. In the river, so whatever, something here, got this idea. Spray your boots, and then one is dirty, the other is not. This is a good product. They're making arrangements. You see, this is carbon made of nanotubes. Oh yeah, what happened? Why it was quiet earlier when I was playing it. Something happened. Maybe something happened to the music. Play. You can arrange the tubes any way you want, so this will be strong in one direction and bend in the other. This. Get rid of this. They cover those things, the blade, the certain. Oh, there is the airplane. They're going to coat the airplane with nano coatings, different. Because there is always friction when the airplane is flying, right? And when they make it lighter, they're covering. They make them from different, they're lighter, right? It's the fuel efficiency. This one is so much more. Instead of top, if this is all open, imagine this is all glass and you're in the airplane, it would freak me out. Think of it. Way. Here. Bucket bed. I don't know, because they call those things a bucket tube. Yes, yeah. I don't know. We got the airplanes with cars. We do the cars. Whatever. Okay, here is the special car. They're actually very good for solar batteries. Blah, blah. Okay, the car will give you a thing. That is, now, they make it so clean. I mean, you know how they get thinner and thinner, I guess, because they're strong. You can, them things like this a little bit. Can be the window. You can see in the movie, people use the glass, but they actually can see on one side. Get a monitor there. There are all kinds of things you can do. This is an old video again. So there are two examples. So, but think, okay, so what would you do? I don't know. Should we be excited about the progress, or should we stop? Because, so those things are implemented many places, right? People implement the new companies. He's using it in their cars. Customers probably have no idea what it is. They just buy it because it's cool. But, like, should we stop and not implement them until we do more research on the health effects? What do you think? Yeah.
I think there's so many benefits it'd be done to make sure there's no like
Outweigh the benefits, yeah, because I mean, like the Teflon thing, you know, these are like forever chemicals, so there's so many, you know, they make them, but then find out, oh, I don't know, yeah, lead in paint, yeah, and there is, so
Did people die from that?
for what, lead?
The lead from
Oh yes, there is, especially little kids. Yeah. No, I don't think so. It is lead, but yeah, I don't think. Wait, can you? You have interesting questions. I don't think. This is different lead. Okay, this is lead, different, and especially the paint. Yeah. In dogs, your dogs can. Let's see how the dogs can. You know, in the dog can. But there were cases, and I had it somewhere printed. Like many cases, but there was one family in particular. They were refugees from one country. You know, they came to find a new future in America, and they were in some kind of apartment complex. Which most of the apartment complexes, if they're built before, like I don't know, the 80s, they have lead paint. Somewhere or another there was, and even if you cover it, they didn't strip it. You know, it's still there. The ceiling asbestos. This is this. Mm-hmm. Yeah, as long as you don't disturb it. Yeah. Yeah. Most of the old apartments, they have it. This, and it is true if you don't. Anyway, this is actually we talk about in another chapter, but this is a good thing. Okay, so the lead paint and the asbestos. Asbestos is one of those things. They found it. Again, I have a whole PowerPoint on this. It's the greatest thing ever. Actually, they knew it from centuries. They used to make the wicks for their lamps from asbestos because asbestos is something which, you know, it doesn't burn. You know, you can use it to have the oil, you know, to burn the candle, but it wouldn't burn. So they used. It's not a chemical, it's a natural actually occurring. It's a rock. You find it, and it's kind of rock which is like a string. You know, it's a mineral. But again, it have a coating on asbestos. But they used to, you know, when you cremate some boys, they used to cremate people, you know, they cover it in asbestos cloth, something made out of asbestos. And then, you know, because of the high temperature, the body inside burns into ash, but the cloth doesn't. So they have all the ashes in there, you know, carry them around. But it is poison. You know, if you inhale it, you get mesothelioma after about 40 years. So anyway, so it was so, they put it everywhere. Where is this? Let's see if we're talking about it. Let's just do this. What's the point of talking about it and then not seeing the pictures? It deviated from our populi. It should be in the chapter about air pollution, I guess. Right here. Let's see if it's here by any chance. No, it's not here. Okay, it's not here. Oh, it's right here. Oh, look how lucky you are today. Okay. Here we go. Asbestos. So let's just, okay. So this is, it's in the air pollution because you breathe, what it is, it's a fiber, right? It's a rock, which look, here is the rock. Hold on, right here. It's a rock. It's right, where is the rock? Come on. Here is the, oh my gosh, I removed the rock. Okay, it's a rock. Where is the rock? Oh, here is the rock. Okay, it looks like that. You can actually find it. There are cities in America which are kind of bent, like the one in Pennsylvania, because everything is made of the rocks are asbestos. So it's dangerous to live because if you breathe, when it becomes, you see how it's a rock, but it's, you can strip it like becomes like a fabric in a way. You know, it is, and that's why you can make clothes and everything. So there are several types of asbestos, but they used to put them like this tile contains asbestos because it does not burn. So they use it for everything which you hope to be, even in clothes in your baby, you know, if you don't want the baby to catch on fire, you know, how right now the synthetic clothes, they catch on fire very fast. there is warning. Careful, do not, keep away from fire. Okay, so they look like this under microscope. I used to do this in this lab. This was my job, one of my jobs. But here you can use it as a wick. They knew it way before, during Jesus' time, way before that. They use it, to burn their bodies. It doesn't. It's like, and then some people, no, it just doesn't burn. I don't know. I mean, there could be some certain temperature when you melt, but it's probably very high. Okay, some people are, they're scammers. They sell a little piece of asbestos because they don't burn. Say, oh, this is part of Jesus' cross. It's so special. But there is also, in the past, how they used to have those big opera houses or theaters where they used flames for lights, and they had all the time fire. The big curtain catches on fire. So they used asbestos for those fire curtains. Grace is like nodding like she knows about those theaters. So what do you know? Did you play drama? Are you in drama or?
Yeah, I was a lot, and I
Oh wow! In your school? Weren't you homeschooled?
No, I was homeschooled.
Okay, so which school did you do the drama with?
I went to Connell High School.
Oh, okay, they had drama. Oh, I didn't know. Like they say about Jesus, nothing good can come from Nazareth. But I'm like, I didn't know that Cornell can have a drama team. But I guess it did. Was it any good? As good as Hanford High School? Oh, Hanford makes big productions.
Well, we're a very small town and a very small school. Yeah, so it's like all the little farming towns all went to Connell for school. And I mean, for the size, I think it was a pretty good, because I also did music. I did choir and band.
Oh, wow.
And so kind of all three of those departments were led by the same two people. So anyway, I did a lot with that, and we would go to theater productions for choir and stuff like that. So I know a lot about theater and history.
Oh, that's good, because this is what the big problem was with the flame and those, the course. But anyway, so here Benjamin Franklin, he actually made a little purse. See, he made himself a purse made of asbestos so he can protect his valuables when he went to Europe. His passport and stuff. It's from the National History Museum. And then, they put it's everywhere, in the car, the brakes. Yeah, everywhere, because it's scrubbed your teeth. The telephones, they're made of this special, black material. One I've seen old phones. Or it's even now it's in the brakes of the cars. I don't know if you work for cars, but because when you press the brake, it's friction, so you don't want this to catch on fire. So they put asbestos on the brake pads. Then put it everywhere in the house, from the floor. This is like the Wizard of Oz, I guess, some play, Grace. And the broom was, yeah. The broom was made out of asbestos. I don't know if they're trying to put it on fire, but they toothpaste, orange juice too. I don't know. Even the wine, the process they used, so they use filters, and even the mail carriage. The mail bags are made out of asbestos because you don't want the mail to burn. So people didn't know that. They're like, oh, it's so cool. Even the cigarettes, actually, the filter were made out of asbestos. Can't. So there was asbestos lady. They made even a comic book. Hey, this was such amazing thing. Is this Spider-Man behind her? Who is this red thing? I don't know. Red and blue, some other, but. So asbestos, you can find it everywhere, blah, 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 blah. So we're just covering next chapter. This is, it's everywhere, because I worked in this lab and they bring from Hanford, they're demolishing the buildings. And they bring me sample of everything, the ceiling, the walls, the paint, the tiles, everything which is there, towels, they bring it to you. Because if there is asbestos, they need to handle the demolishing different. People need to wear respirators and stuff. So you had to test everything there, before. So it was in everything. And so in all the houses, it's in the ceilings. Again, if you don't disturb it, it will stay there. But if you start making holes, it can breathe. And this is the problem. If it gets in your lungs, then it's stuck there, and it takes about 40 years for it to actually develop into this cancer. So you don't know it. It's like the insulation in your roof. If you have roofing, this thingy, they were made of asbestos because you don't want your house to catch on fire, to burn. They were excited then. It was, this is how it was, because they were thinking it's so great. That's why I'm making the parallel with nanotechnology. So this is what it was for years. So right now, actually, if you go, and I did this, I checked it, you can go Home Depot and buy tiles for your roof, the flat thingies. They do have asbestos, especially the one in China. Yeah, the little rubber thingies with the little rocks on top, whatever those things. The tar, there is asbestos there to most of them. It's most because, they're still in China, actually, in some kids' games. There was CSI game made recently. I got another picture, but the white powder they're using for fingerprints actually had a lot of asbestos. Somebody caught it, but okay. Anyway, so it's found everywhere. And when you inhale this thing, it's stuck there. Here, let's see more. So in the past, during the, especially insulation, if you have an old house, look at, how the pipe, the electrical was, the insulation, it used to be made out of asbestos inside. So this is another thing to watch. And boiler, the thing, hot water heater, usually the insulation inside was asbestos. And so during the World War, this was asbestos here in all those. In the big, like, boats or ships, I'm not a ship, but ships, they had all those people working there, all the soldiers, and there was a lot of asbestos. So many of them, like 40 years later, they developed this mesothelioma. If you're like in your 20s or 30s during the war and work on one of those, like when you're in your 70s, you get this disease. And I worked with a guy who actually was during the war on one of those ships, and then he got mesothelioma and he died. And they paid him a lot of money because there are many lawyers who this is their specialty, and then you get money, but still die. Okay. So so they're everywhere. So when you see especially strings, I don't know how asbestos strings, like a little, they look like almost silk, very soft, silky things, other examples, all this, oh my gosh. This, this kind of non-burning material, like a blanket, this is also asbestos. Here is asbestos, the things, blah, 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 blah. Okay, have many, many examples. This is, there's so much asbestos in those ceiling tiles. These are new one, probably not. But. Okay, keep going, keep going, keep going. Eradicated? No, China still makes things. I'm saying if you go to Home Depot and buy. Here, no, because we buy things from China, so you're not supposed to. Still in the cars, you still use it in the car. Breaking these parts. And a few, but all the old houses here, they have asbestos. So when actually my bathroom, see, this looks like my bathroom, how it looks, because there was mold, so they broke the wall to see what's in there. They left it like this for 6 months. They just taped it, it's like, dude, there's so much asbestos. Maybe, in my apartment. No, it's not my house, but it's like that. Huh? Yeah, they don't care. They say, it's okay. But then when the people actually came to work, they actually taped the whole thing. They say, asbestos danger, on the bathroom wall. They put a big, like, curtain. Because they changed the whole wall. And I keep telling them, people, we're living like this hole in the ceiling for like 6 months. They made 2 holes just to check what's up there. But they didn't care. But I didn't have time to file a claim. I was like, it's my fault. Yeah. Anyway, keep going. Health effects, blah, blah, blah. I do take pictures. They're somewhere. You're right, but I can't. Yeah, the thing is, I guess if somebody gets sick again, definitely. But maybe they hope nobody would get sick again. So here. So, there is no self-dose. You cannot say, you got 1 fiber or 10 fibers. 1 fiber is enough, really, to get you. There were cases like, because there was asbestos mine, so people go and mine those things, and they bring their clothes to dry cleaning. And one of those dry cleaning girls, she didn't go and work there, but because of all the dust, she got mesothelioma. You know, you can get it secondhand. Then we go to the lungs. Here's example of a guy. He was, you see, all this asbestos stuff working, and then he got some kind of cancer. And blah, blah, blah. Oh, this guy. This is. You don't know who this guy is, actually, because it's an old actor. What's his name? I even forgot. But he plays in the first old movie called The Magnificent Seven. The Magnificent Seven. You ever heard? They make a remake, but the old one when it's black and white. Is it Steve McQueen? I don't know what his name is, but he played in there. He was a good actor. But what happened? You know, he's a star. But when he was in his 20s, he was trying to be an actor. He was working on houses, you know, building stuff, construction. And there was, I guess, a lot of asbestos he inhaled. So then later, this is what he died from, like 4 years later. So it's interesting. Okay. So what we did, we kind of went into. So I know, but so how about the nanotechnology? What's the difference between this and nanotechnology? Tell me. What do you think? Who knows? Nobody knows. It says here they don't know. Right. It says many scientists actually are saying, oh, wait, hold on. Maybe we should do more studies. So what do you think? Should they stop and do more studies? Or we should move on? Thinking about what happened to the asbestos.
I feel like the smart thing to do would be to do more tests, but I don't know if that's, there's a lot of money to be made out of that, and I don't think that's gonna happen.
Yeah, this is what it is. But you know, it would help solve many problems. You don't need to mine for materials. You can make way better one, you know, using this. But it's always the question. So we need to pray, I guess. Our thing, we just pray. And of course, okay. So what we do, we'll stop. This concluded chapter. I had a thing for you, but we have only 4 minutes, so we won't be able to do it. We'll do it next time. So we're going to do a lab. Before we take a break, let me show you the lab. So find the lab. It's called mining something. Let's see. The lab called. This lab is the easiest lab ever. It's called Fossil Fuel Extraction Lab. Right here. This one. So this one, everybody does it by themselves. It's individual lab. Isaac? You need to cut the rig, but technically what you're going to do, you're going to be mining cookies. I think this is $5 a box, so these are expensive cookies. So does anybody read the lab by any chance? No. So you'll be mining, so your cookie will be the earth. And you can eat, I bought some boxes so we can use this one. You can eat your own cookie. Because what you're going to use is, you're going to use a toothpick to mine your stuff. And feel free, you know how in the real mining, they actually do water, spray water, they actually some use high pressure water to remove. Feel free to make your cookie a little wet if you think. But you're going, for example, let's see this best. You can eat a little cookies, this is the earth. It's going to be a competition. So there's 2 types of things, white chocolate and nuts, macadamia. So this is, let's say the white chocolate will be the oil, and the macadamia nuts will be the coal, right? So you're extracting very steps here, but Elizabeth is going to try to, this is the earth. So in the end, we're going to compare first who destroyed the earth, the leaves. Individual, you know, and then who extracted most of the materials. Which would be the nuts, and then 2 piles. One is the chocolate, the other is the nuts. So you're going to use toothpicks to do that. Right. And again, you need to put a little water on your cookie, but we have to compare. So look at it now. They put the raisins and stuff, we don't have raisins, we just have 2. But we need to to draw pictures before the mining and after the mining of your cookie. And in the past, I really wanted to measure your cookie, then measure, measure the weight of your nuts, measure the weight of everything. But to make it easy, we just do a visual examination. We decide as a class who is the most. Got it? So again, you can one of the box use for mine, the other you can use, and then you can use your own mine at the end. Yeah. And you can use two toothpicks, yes. So let's see who will be the best miner, who will mine the most without.
I think Grace will be the first one. She is mining.
Yeah. But she's mining now with old. And some people are minor with tea. Okay, there is a cookie for you. Don't be over there. Just for the try to get the least damage. Do the knock there. I know it sits. Right. For Jenna, and then you can hear another cookie. I got 2 boxes, so we can eat one. And yeah.
Oh, he did.
Oh, okay.
Yeah.
This is a fun one. It's just a rough sketch, right? I wanted to show the stuff. Then extract it, and then last time I kept milk, but now I'm not doing like one of people, whatever, we don't want milk. Yeah, draw the receipt before I know it is instructions. They just say the page, 416 if you didn't read all the other pages. And here, feel free to, there's how many cookies in one box? Yes, feel free to the other. I really like cookies. Oh my goodness. One, two, so feel free to get a cookie if you're hungry. Thank you. It is fun. It's just a fun one. And now with this cookie. Let's see this for the $5.
Where the other ones go?
They're pretty good. That's sweet. I know that much. Yeah, they're pretty good. I keep it away.
Can you tell if this is anything or not?
I know it's hard to see. All the same color.
Again, you can put some water.
I'm afraid.
A little bit already extracted some of those. Oh, we need to stop the recording.
Okay, now whoever sees that video will see what they were seeing at.
Cookies. Let me show them the cookies. Hold on.
Yeah.
Oh, they don't. They need to find. They need to repeat the